Hello everyone. Today we are going to be learning about mathematical induction. So this video is going to be covering just the standard induction. Next video is going to be covering what's called strong induction. So mathematical induction is a way to prove some kind of statement is true for all of its cases. And we do this in two steps. First we have what's called the base step, or the base case is actually what I'm going to be writing. And essentially, we have to show that that statement's initial value is true. Okay? We also have what's called the inductive step. And basically, for the inductive step, we have an arbitrary value like k, and we have to show, or actually we're assuming and we're supposing that p of k, or that statement's kth value, is true. We're supposing that it's true, and if it is true, so if p of k is true, then that next value is also going to be true. And if we're able to show that pk plus 1 is true, and if we have both steps done, then we can assume that the statement is true. Let's say we have something like 1 plus 2 plus 3 plus n, and we want to show that n times n plus 1 divided by 2 is a way to represent the left side. How do we do that? Well, again, we start off with the base case. So the base case is going to be that first value right there, 1, and we have to show that the right side is also going to be 1. So let's take a look. 1 equals 1 times 1 plus 1 divided by 2. 1 plus 1 is 2, and 2 times 1 is 2, and 2 divided by 2 is 1. So we verified that the base case has been shown to be true. What about that second one, that inductive step? How do we show that this is going to be true for all cases? Simple. We start by supposing that that left side, for any arbitrary value k, is going to be the same for that right side. So we're supposing this is true. We haven't shown it is true yet, but we're going to suppose it's true, so that way later on we can prove it to be true. Okay. Now that we suppose this to be true, we're going to try to show that k plus 1, p of k plus 1 is true. Plus k plus k plus 1 equals, and I'm going to move this a little bit to the right here so I have a little bit more room. Basically, it's going to be k plus 1 times k plus 1 plus 1, all divided by 2. Right? So the next step is, since we're supposing that p of k is true, we can actually replace the left side with the first right side. Oops. The first right side. So we can actually just write k plus 1 divided by 2 plus k plus 1 equals k plus 1, k plus 1, plus 1, divided by 2. Now all we need to do is do some simplification and show that these two sides are equal. And you'll find that that is actually the case. If we simplify the left to look more like the right, we get the same answer. And since these two are equivalent, we have successfully shown that this is true.